Howdy guys, so here's another example of a proof with mathematical induction, but this time we have trig, which is going to make it interesting. So we're going to use the process that we've been using to do this. So obviously our first step is our PN step. So there that is there. I didn't think you needed to see me write that out. Now we get on to our basis step. So if n is equal to 1, left hand side is equal to 2 cos 2x, because that's the first term. Now if we look at the right hand side, now this is where it's going to get a bit trickier than what we're used to. So the right hand side is going to be sine. Now we're going to have a 1 here where the n is, so it's going to become sine 3x. I probably don't even need the brackets there, to be honest. I'll just write 3x, because that's going to change to a 3 over sine x minus 1. Now at the moment this doesn't look anything like that. So we now need to manipulate this to get it to look like this, which means we might have to get our little handy sheet out. Hopefully you've still got those that Miss Matt gave us that's got all the rules on it. So the first thing we're going to do is we're going to split this sine 3x into 2x plus x, and I'll show you why in a second. Okay, so we've got that. So we've made this 3x is 2x plus x. Now the reason we can do that is we can use our angle sum identities. So when you've got, so maybe I'll put it over here. So if you've got sine A plus B, that's going to be equal to sine A cos B plus cos A sine B. Now we're using this one because we need to bring in causes. At the moment we don't have a cos at all. So if we do that, we're going to get, what are we going to get? Sine 2x cos x plus cos 2x, which is what we want. Let's see now how we've got this cos 2x, sine x over sine x minus 1. Okay. Now, next thing we're going to do is replace this sine 2x. Now we can replace that with 2 sine x cos x plus cos 2x sine x minus 1. Okay, now again, this is when I suppose you're going to need to grab all your rules to try and remember them, okay? That's where this is going to get a little bit hard. Okay, now we can pull out sine x as a common factor. So we've got 2 cos x plus cos 2x all over sine x minus 1. They're going to cancel, which is then going to give us 2 cos squared x, because these two cos x's can do that, plus cos 2x minus 1. Now if we rewrite this a little bit, we've got 2 cos squared x minus 1 plus cos 2x. Hopefully you see that this here is also equal to cos 2x. We've got cos 2x plus cos 2x, which gives us 2 cos 2x, which is equal to the left-hand side, which was really long. But now we know from there that P1 is true. So that's definitely the trickiest we've seen in regards to that sort of question, for sure. Now we can get on to the next step. So step 3 is if PK is true, then 2 cos 2x plus 2 cos 4x, I'm going to skip a few, plus 2 cos 2kx, and I'm sorry, I know you can't see the question, is equal to sine 2k plus 1x over sine x minus 1. Now we'll do k plus 1. So then we've got 2 cos 2x plus, let's skip 2 cos 2kx plus 2 cos 2k plus 1x. And we should probably put that all in brackets really, I would say, is going to be equal to sine of 2k plus 1 plus 1x over sine x minus 1. Let's simplify that a little bit. We're going to have sine 2k plus 3x over sine x minus 1. Now, okay, of course that's not all going to move there. If we look at the left-hand side, so we know that the left-hand side is going to be equal to sine 2k plus 1x over sine x minus 1, because that's what we're going to sub in for this bit here. But then we're going to have plus 2 cos 2k plus 1x. Okay, and now we've got to go, whoa, right, what are we going to do here? So let's multiply, let's get common denominator. So let's multiply this one by sine x. So we'll end up with sine 2k plus 1x over, well actually let's just do it all in a step. So if we're multiplying this bit here by sine x, that means that we're going to have plus 2. What are we going to have? Sine x. Let's put the sine x first. Cos 2k plus 1x all over sine x. And we're going to leave this minus 1. I didn't touch this minus 1 here because, as you can see, we want to get it to a minus 1. So if we have that minus 1, that's the first bit we've got right. So when we multiplied this bit by sine x, I sort of put it in here, and obviously we multiplied the bottom of it by sine x so we can have it all over a fraction. We've got the sine x on the fraction, so that's good. So we're getting closer, okay? But now we've got to have a look at what we've got next. Okay, so the next thing I'll be doing is we currently still have a cos here, and we want to get rid of that because we know we're trying to essentially find our right-hand side, which is this, and there's no cos in that. So I'd be looking at, okay, what do I have on my formula sheet and what can I use? And I've already kind of written it down here for us, but we could use this 2 sine A cos B is equal to this. So we're still going to leave the first term as it is. Okay, plus 1. All right, now we're going to figure this out. So it's going to become plus sine of x plus 2k plus 1x. Hopefully that makes sense there. And then we're going to have plus sine of the same thing, but this in this case it's minus. So minus 2k plus 1 x. That's fine. So that comes from A, here would be this one, and B would be this bit here. So that is how that works. I know it looks super messy at the moment, but bear with me. So sine x. All right, let's move everything up. Okay, so let's have a look and see if we can try and simplify this. But also don't forget that minus 1 that's still there. I forgot to write that in. All right, I think I'm going to try and simplify what's in these brackets a little bit. So we're going to have sine 2k plus 1 x plus, now what's going to happen in here? We're going to have sine x plus, that's going to become 2kx plus 2x. You can see we've got 2k and 2, but then that's also going to multiply the x in, plus sine, now we're going to have x minus 2kx minus 2x, because again you're going to multiply that in, but the x is also going to come in. They've written this in a horrible way. All over sine x minus 1. Now let's go back, keep going. We're not even going to know what we're needing to look for in a second. So that's going to be sine 2k plus 1 x. I should have a bracket around it there. Plus, what have we got? Sine 2kx plus 3x plus sine, what have we got, negative 2kx minus x over sine x. And we're still going. Now you guys might want to skip some of the steps that I'm using, but I'm just trying to show you every step to hopefully you can help, or it will help you to see exactly what's going on. Okay, so let's pull out. So we'll keep this as sine 2kx plus 3x in this case, but let's try and make this, so let's pull this negative out. So if we pull this negative out, we've got negative sine, and we're left with 2k x minus x. But what I want to do is also pull out that x just within these brackets, so then it can look like this one here, and then they will hopefully cancel. So that was probably pretty hard to see, but if we, so first of all we've pulled out this negative that was there, which we've now got here. Now we're going to pull out an x, so I'm just going to get rid of this. I'm going to pull out an x as well. So if we pull out an x, we've then left, we've already pulled out the negative, so we're left with 2k plus 1 because of the negative that's already come out the front, because if that negative goes in, it makes both of them negative, all over sine x minus 1. Now as you can see, these are written slightly differently. You've got the x at the front here, x at the back, but they're exactly the same. So you've got sine 2x, 2k plus 1 to the x minus that, they will cancel. Now I think we're getting closer. So now we're left with sine 2kx plus 3x all over sine x, which is nice. Now what we were trying to find, if I go and write it back down. Okay, so I've just written in green what we need, and I think we're almost there, except I forgot that pesky negative 1 again that we always keep forgetting. Okay, so let's just simplify this one. So sine, let's pull x out, and we'll put it at the end, because I like to put things at the end sometimes. Sine x minus 1, so that's equal to the right hand side. So that was huge and tough, and there's lots going on, and that's okay. We will work through these, don't stress too much. This example is in the textbook. If you want to have a look, feel free. I feel like they skip so many steps though, which would make it a heap harder. So even if you just have a go at listening to this and writing it down, that's going to be better than nothing, and we'll be able to have a look at some of these in class on Wednesday, hopefully. Thanks, guys. Oh, sorry, I need to write down that sentence. I'll do that now. And there it is. Don't forget that wonderful sentence that you need to include. So I hope you could follow along for the majority of that. Again, as I said, it's really hard, but good luck. We'll do some of these in class together.